Alright, so we have three examples left here. So in this last example for number 1, we need to rewrite that one as a base of 2. So just to start off here, guys, do you guys remember how to write 1 over 64? How can we write that as an exponent? So if you guys remember there, our negative exponent will flip your value. So what we can do is we can rewrite 1 over 64 as 64 to the negative 1. So those are equivalent forms. So that's the same as, what if we had 1 over 2 squared? So that exponent there is going to become negative, and you're just going to flip it. So it would be, if you guys want to see that, 2 over 1 to the negative 2, that would be then equal to 2 to the negative 2. Okay? So here's a quick little example of what happens with negative exponents. You've worked with it a lot in this course with previous courses, so hopefully we should be alright with negative exponents. But if not, there was a really quick tidbit of what was going on. Okay? So moving on here, we can write 1 over 64, that we can rewrite as 64 to the negative 1. And that's also the exponent of 1 over 3. Then applying those exponent rules, we can rewrite that as 64 to the negative 1 over 3. And just as a quick note there, ladies, if you wanted to skip this part, if you know that automatically your exponent would be negative 1 over 3, that is absolutely fine. So you don't need to write the step. I just wanted to write it there so you guys see step by step exactly what to do. Okay? So then what we can do is, let's rewrite 64. Now if you guys can't think of that base as it is, you know what? Start with, even just put 64, the square root of 64 into your calculator, and what you find that is equal to 8. So we could do 8 squared to the power of negative 1 over 3. So 8 squared is 64. Then, using those exponent rules again, we'd have 8 to the negative 2 over 3. Then, hopefully, here we would know that we can rewrite 8. That is equivalent to 2 to the power of 3. So we'll rewrite that there. So we have 2 to the power of 3 to the negative 2 over 3. And then simplified, that would be 2. And those 3's would cancel out or divide into each other, so we'd have 2 to the negative 2. Okay, so there we have, in all three of those examples, we have changed all of those to a base of 2. Okay, so now let's move on to example number 2. And here what we have to do is we have to solve the equation 10 to the x plus 4, and that's equal to 1000 to the x minus 4. So your first step there is try and write this as equivalent bases. So can we write that 1000 as a base of 10? So if you can't, then you would use either trial and error, or you could graph it. Or what you could do, hopefully we should know that we can write 1000 there as a base of 10. So we'll start, we have 10 to the x plus 4 is equal to, and 1000 there is 10 to the power of 3. And that's all to the exponent of x minus 4. So from there we can distribute. We'll use those exponent rules. So we have 10 to the x plus 4. And that is equal to 10 to the 3x minus 12. If you guys wanted to, another form that you could also write that would be 10 to the 3 times x minus 4. So you don't have to distribute that in. Eventually, at some point, you'll probably have to, but if you guys didn't want to, you could also leave that in that form. It's the exact same thing. So now that we have similar bases, now we're just going to look at just the exponents. We have x plus 4 is equal to 3x minus 12. So you're going to move exponents over, or you're going to isolate the variables. So first we'll start by subtracting 3x. So we have negative 2x plus 4 is equal to negative 12. Then what we're going to do here is we're going to move 4 to the other side. So we'll subtract 4 on each side. And I'm just going to keep writing this going to the right there, guys. So we have negative 2x is equal to negative 16. Then, continuing to isolate that variable, we're going to divide by negative 2. And what we have here is that x is equal to positive 8. Okay? So you guys could check this either by graphing. You can graph, you have those two options. So to graph, you could graph them independently. So you could graph y is equal to 10 to the power of x plus 4, and y is equal to 1000 to the x minus 4. Or you can move everything to one side and graph y is equal to 10 to the x plus 4 minus 1000 to the x minus 4, and look for where your x is equal to 0. Okay? And then so the above one, just look for where these two here intersect. Okay? Alright, so moving on, number 3. Here we need to solve for x in the equation 7 to the power of x is equal to 3,579. And we're going to express our answer to the nearest tenth. So already right there, that kind of gives you that hint that we need to round our answer to the nearest tenth. That right there is going to tell us that there's going to be no way we can write 3,579 as a base of 7. If you guys wanted to, try your hearts out. You're actually not going to be able to find a way to make 3,579 as a base of 7. Okay, so there's going to be a couple options that we can do. So you guys can either solve by systematic trial or trial and error, or you guys could also graph. So let's look at both of those. Sure, let's do it. That would be awesome. Alright, so let's first try trial and error. So we're just going to look at where we have that variable. So we're just going to look at 7x. So for your first one, take a guess what would realistically get you close to 3,579. And maybe you could guess, I don't know, let's try x is equal to 4. So when you put 7 to the power of 4 into your calculator, you guys will notice that you guys get 2,401. So clearly that's it's a good distance away from 3,579, so let's keep going. So let's try x is equal to 5. So put 7 to the power of 5 into your calculator, and you guys should find that we have 16,807. That was quite the jump. Holy wow. But now what we know is that our value, our x value, that will make this true is somewhere in between here. And also taking a good guess, it's 3,579 is pretty darn close to 7 to the power 4 when we compare it to 7 to the power 5. Like this one is just way out to lunch. So there would be really not much of a point in guessing high decimal points. So let's maybe start with something lower. Let's try x is equal to 4.2. So put that into your calculators. We have 7 to the power of 4.2. And what you guys should find is that we have 3,543.3. So that's actually pretty close. We're only about maybe 30 off. If you guys wanted to double check, try putting in x is equal to 4.3. See what you guys get into your calculator. And we have 7 to the power of 4.3. And there we get 4,304.5. So that right there, that's already getting way too high. So probably your best guess here, let's say that x is approximately equal to 4.2. Okay, so that's just using trial and error. You know, some people prefer it, but if you want to try the graphing method, that is absolutely fine. So I'm going to quickly switch over to our graphing calculator to try this out. Alright, so I've got my graphing calculator out here. So let's go through both methods. So the first one is when we're graphing to solve, you could solve it each side independently. So we could graph y is equal to 7 to the power of x. And then we can graph the right side, which is y is equal to 3,579. And look at where those graphs intersect. So I'm going to zoom in here. And let's look at what happens there. So y is equal to, oh boy, we're going to have to go pretty far out there. So you guys will have to probably adjust your windows. We need to go all the way up to 3,000 there. So, oh boy, let's get on zooming. Aha, here we are. Okay. So you guys are going to look at that point there. If your graphing calculator will find that point of intersection. But this one here, we have x is equal to 4.2. So that's actually exactly what we had guessed. So that was a pretty good guess that we did, or well, we did through trial and error. So there's one option there. So this blue graph here, remember that's your graph y is equal to 3,579. Then this red one here is y is equal to 7 to the power of x. So look where those two graphs intersect, and there you find it should be at, your y value should be at your 3,579. If it's not, you're not sitting on that second line here. This one will only have the same y value, so find out where that intersection point is, and here we see that x is equal to 4.2. So that was a good guess on our part. Okay, so the second way that we could do this is if we just used one graph and we moved everything to one side. So we'd have 7 to the power of x minus 3,579. And so then what we're going to have is, where does that graph touch 0 or hit that x-axis? I have to scroll all the way down there. Alright, let's zoom in there. So you guys will probably have to adjust your windows there again. But what we'll notice here is that when we have y is equal to 7 to the power of x minus 3,579, that x-axis where it crosses that x-axis, we have 4.21, or what we'd round is to 4.2. Okay, so there's those two different options for graphing. We've looked at systematic trial and error, and we've also looked at trying to rewrite equations or functions as the same base. So there's a bunch of different options for you guys there, so you guys can get onto your homework. And so this was the last section, so tomorrow we'll have an assignment, and then in a couple of days we'll have a test. So have fun.